So welcome everyone to Math 128. So we're going to continue where we left off. If anyone has any questions, let me know. So let's see. And the first assignment is posted early. But like I mentioned, that's just in case anyone wants to work on it. It doesn't have a due date yet. Once we finish chapter 1, then we'll figure out the due date. Okay, so recording, sharing, good. So the previous thing, previously what we did was we reduced fractions to lowest terms, and then we also learned how to convert from mixed numbers to improper fractions. I think that's what we did. I might often get confused because I'm teaching different courses that have overlapping material, but I think that was this class. So yes, so we're going to continue. Let's just do one example of converting from a mixed number to an improper fraction, and then we're going to learn how to do the reverse. So let's do 6 and 3 over 5. Okay, so to convert this to an improper fraction, it's always the same formula. It's always the large number, 6, or I guess you could say the whole number, times the denominator plus the numerator. And that is what you get for the top. And then the bottom always stays the same. So the bottom will just stay as 5. So 6 times 5 is 30. So 33 over 5. So that's how you do those. It's pretty algorithmic. It never really changes. Although people still make mistakes. Sometimes they'll do like, what do people do? They'll do like 6 plus 5 times 3. But you don't do that, that'll give you the wrong answer. You always just do it exactly this way. And then a lot of times people will forget the 5 on the bottom. They'll just state the answer is 33. But obviously 33 is a lot bigger than 6 and 3 over 5. So you got to remember the bottom part because you are converting it to a fraction. So that's how you do it in that direction. Now for the other direction, it's a little less algorithmic. So the easiest way is let's just do an example for this one. I'm just going to go to a whiteboard. Man, it's so weird that this class starts at 1. It just feels like, I don't know, feels weird starting at 1 rather than like 1:30. Okay. Let's see, I'm just trying to find my place. Okay, so the example was 31 over 4. So here is an improper fraction, and now we want to convert it to a mixed number. So there's a couple of steps. So the first one is you look at the bottom number and you ask yourself, how many whole times could this bottom number go in to the top number without going over it? So you literally just count how many times it goes in. So like 4, that's 1, 8, 12, 16, 20, 24, 28. And if you go above that, then you'd go too high. So I just counted that it went in 7 times. It goes up to 28, but it goes in, there's 7 4s going in there. So 7 is what you use for your whole number component. So that's always how you do the whole number part. You just count how many times it goes in. And it went up to 28. And then what you do for the next part is you count how many numbers remain. So you went up to 28, so 29, 30, 31. So that's 3. And you use that for your top number. And then, as you could probably guess, the bottom number is always the same. So that is just going to be 4. So 7 and 3 over 4 is what you get for that. So like I said, a little less algorithmic in the sense that like there's no formula for this one. You just got to remember how to do it. And some people will make the mistake of putting like 28 and 3 over 4. And I can understand that mistake, but you don't use 28, you just use 7. You just use the number of whole times it goes into the top number. So this one is correct. This one's wrong. Okay, let's do one more. And be sure to practice this because you know, a lot of the times people will look at this and they'll be like, okay, I get it. You know, it's easy. But then those are the times where, like, when the test rolls around, people forget how to do stuff. So a lot of the times it's the easier stuff that it just leaves people's brains. Let's do another one. So 17 over 3. How many times does 3 go into 17? So 3, you don't have to actually like count this way, but whatever works for you. 3, 6, 9, 12, 15. And if it went any more, it would go over to 18. So it went in 5 times. So 5 is your number. And how many is left over? It went up to 15, so you count 16, 17, 2 left over. 2 over 3. And let's see. Yeah, someone said 5 and 2 over 3. So 5 and 2 over 3 is what you get for that one. You okay, buddy? Okay. Should we do one more? Let's just do one. We'll do one more. And there is a bunch of questions in the PowerPoint, and then the answers are included. So use those. 59 over 11. So this one's not bad. So how many times does 11 go into 59? Well, it goes up to 55 because you got, you got 11, you got 22, you got 33, you got 44, you got 55. So it goes in 5 times. And that brings you up to 55. So then you got 4 left over. So you got 5 and 4 over 11. There is a pretty easy way of checking these answers. You could just take this mixed number and use the previous formula to convert it to an improper fraction. And if you get the same as what you originally had, then you got the right answer. So like in this case, checking this is kind of trivial because it's usually pretty obvious if it's right or not. But in this case, you could do 5 times 11 plus 4 over 11. So that's 55 plus 4 over 11. And you get 59 over 11. Da-da-da. Your answer is correct. You don't have to do that because there's no point in doubling the amount of work that you're doing, but it's, if you want to check, you can do that. So I think that's it for this particular lesson. Yes, there's a link to a Math is Fun article online. It's a website. It has a lame name. I realize that, but it's a really, really good website. It's the only website that I always check before I write a lesson because they always do stuff better than me and explain everything better than me. So it's like, I always check first because later when I check, it's like, oh, I got to redo this because they're so much better than me. Okay, so let's go to the next thing. Does anyone have any questions? Everyone seems good. Okay, share screen. Let's go to, so the next one is 1.2. And if you can't, let me know if the screen sharing stops working, because sometimes when it switches, it stops, but it says it's sharing. 1.2, multiplying and dividing fractions. So this chapter or this section is super hard. I'm just kidding, it's really easy. Yeah, multiplying, dividing fractions is something that sounds difficult, but it's super, super easy. Adding fractions, which we'll do later on, is surprisingly a little more difficult. Multiplying and dividing fractions, they pretty much just set it up in the easiest way possible. So let's just do some examples. Oh, and here's the general method. You multiply your top numbers together. That'll give you your top number. You multiply your bottom numbers together. That'll give you your bottom number. And that's all you have to do. And that's fraction multiplication. Not too bad. So we got, let's do this one. 2 over 3 times 4 over 5. So top numbers, 2 times 4 is 8. 3 times 5 is 15. Bam, 8 over 15, done. Reduce your answer if you can. This one is not reducible because, yeah, 8, you could take out like a 4 or a 2. 15, you can only take out a 3 or a 5. So they don't have any common factors to each other. Here is another one. So 5/3 times, hold on, I want to make this darker. Oh, I guess I can't. Whatever. 5/3 times 2/10. Now, for this one, the answer is going to be reducible. You could actually deduce that just by looking at this question, because you get a 2/10, which is a reducible fraction. It could be reduced to 1/5. So if you have something that can be reduced in the original question, then typically your answer will be reducible, and there will be a factor you can take out. So let's do that. So anyways, 5 times 2 is 10. 3 times 10 is 30. So we got 10/30, and yes, we can reduce it. We can take a 10 out of the top and the bottom, or you could just scratch out these zeros. That's probably the easiest way to do it, and you get 1/3. You could do stuff with zeros like that. You could scratch out zeros as long as you scratch out the same number of zeros on the top and the bottom. So if you scratch out like 3 on the top, you got to do 3 on the bottom no matter what. Just in general, whatever you do to the top, you got to do to the bottom. So that's multiplication. There's not much else to say about it. I'm not going to go through a ton of examples because literally all we're doing is just multiplying numbers. But there is another interesting component to this, which is cancellation, which is a pretty broad subject. It's something you can use virtually in any area of math, not just fractions, but literally everything. So let's look at what cancellation is. So the nice thing about multiplying fractions is that when you initially see the question, it's easy to see what factors the number has, because the factors are literally exposed. Like we have a factor of 5 on the top, we got a factor of 2 on the top. On the bottom, we have a factor of 3 and 5. It's like they're already broken down. So a lot of the times you could just cancel out any common factors that you see on the top and the bottom. Like in this case, there's a 5 on the top, there's a 5 on the bottom. So you can just get rid of it because they cancel each other out. So let's do some of these. Let's do this on a whiteboard. And with this cancellation, you're not obligated to do it. It's just kind of a tool and another option. And some people find it easier to use cancellation rather than just doing standard multiplication and then reducing at the end. Let's see, let me just find my, okay. So let's do this one, 5/3 times 2/5. So like I said, we got a 5 on the top and a 5 on the bottom. So goodbye 5, rah, rah, rah. Ooh, get out of here. And you just end up with 2/3 as your answer, 2/3. So that's cancellation. As long as you treat the top and the bottom equally, you can directly cancel out numbers. You could do the equivalent of canceling out the same number, which we'll look at. You could also just cancel out any factors that are hidden in the top and the bottom. So there's kind of different ways of doing it. Just directly canceling is, of course, the easiest and simplest way. But let's look at some other methods of cancellation. 3/2 times 5/9 times 3/7. Good stuff. Does anyone see anything that we could cancel out hypothetically? We got some 3s, we got a 5, we got a 2, we got a 9, we got a 7. Let's see what everyone is saying. Exactly, someone pointed out that you have a 9 on the bottom and you don't visually have a 9 on top, but you do technically have one because you got a 3 times 3. Because keep in mind, it's multiplication. So you do have a 9 on the top and a 9 on the bottom. It's just kind of indirect. So you can cancel out all of those. Let's see. And someone said 5/14 will be the answer. Yep, exactly. So let's scratch these out. And again, as long as it's the equivalent of the same number. If you only scratched out, like if you scratched out the 9 and only 1 3, that's not okay, because you took a 3 out of the top and a 9 out of the bottom and you changed your fraction. So you got to do both the 3s so that you're technically taking a 9 out of the top and the bottom. And then you get 5. And on the bottom, 2 times 7 is 14. And if you happen to scratch out all the numbers on the top or the bottom, you just replace it with a 1. Because a lot of people are like, what if they're all scratched out on top? Then I got nothing. In that case, you got a 1. What else? Let's do another one. The next one is super easy. Let's go to a more complicated one. 7 over 9 times 3 over 4 times 6 over 21. So for this one, we have a lot of options. What do you guys want to cancel out? Does anything jump out at anyone?
7 times 3 is 21.
Exactly, perfect, yeah. And let's see what so someone also said, someone's also different ways that you can do it, but let's go with the 7 and the 3. So notice that 7 times 3 is 21, and bam, we got a 21 on the bottom. Perfect. Let's scratch all of those out. Goodbye, goodbye, goodbye. And you could still take some stuff out at this point, because you don't have any direct numbers common to the top and the bottom, but you do have some factors present in the top and the bottom, just like when we were reducing to lowest terms. So for example, let me just check so for example, you could take, if you want to, you could take a 3 out of the 6 and a 3 out of the 9. And that's okay, because you're taking the same number out of both of them. Or you could take a 2 out of the 6 and a 2 out of the 4. Again, as long as it's the same number. Let's do a 3. Let's take a 3 out. So when you're only taking out a factor, what you do is divide this by 3 and divide this by 3. Virtually the same thing we did when we were reducing to lowest terms, except all the factors are kind of more visible. And then you just see what you get. So 6 divided by 3 is 2. 9 divided by 3 is 3. So if you're taking out factors, you gotta use that method. And then you could still keep going. There's a 2 on the top and a 4 on the bottom. So you could take a 2 out. So divide by 2. Divide by 2. This one turns into a 2. And then 2 divided by 2 is just 1. So again, if everything's scratched out on the top, you just got a 1 on the top. So this looks really ugly, but it just equals 1 over, and then you got a 3 times 2. So you got 1 over 6 for that one. So there is a big advantage to cancellation, because if you did it the old-fashioned way, you might have to remove a really big factor from your final fraction. Like if you did this let's do this the standard way. Oops, I just moved something that I didn't want to move. Okay. Let's do this without cancellation, and we'll see why cancellation does have some benefits. So this is, I need a calculator for this. Let's see, 7 times 3 times 6 is 126. 126. The bottom is 9 times 4 times 21, 756. So this shows why cancellation is good, because if you did it this way, it kind of sucks, like having 126 over 756, and it might not always be super clear what factor to take out of it. In this case, there's actually kind of a trick. First of all, you'll take out a factor of 126, because you already know that the answer is going to end up having a 1 on the top. So 126 is your only option. But there is a trick that you could use to deduce what factor you would take out of it. You could look at what we did previously. Previously, we took out a bunch of factors, right? First, we started with 21. Then we took out 3, and then we took out 2. And I think that was everything we took out, right? So if you actually multiply those together, that will tell you which factor to take out of your final answer, because that's all the factors you took out. So if you multiply them together, that will give you the one big factor, the largest common factor that you would take out of your final answer. So everything always ties together, and there's always like little tricks you can use. Let me just confirm that this, so 21 times 3 times 2 is 126. So that would tell you that for this right here, you'd take out a 126. So that's 1/6. Sometimes you can even just look at the original question and pretty much just like collect factors in your head and do the math, and you could just like automatically deduce what you could take out of the final answer. Yeah, so cancellation is very, very useful. Like pretty much in any area of math, when I see like the same number on the top and the bottom, it's like invisible to me. Like I don't even see the numbers because my brain just like automatically cancels them out. So it just becomes like an automatic thing after a while. Okay, it's 1:30. Let's keep going. Maybe we'll do one more, or maybe we'll keep going. There's another one in the next slide after this example. Maybe I'll leave that for practice for everyone, and maybe we can do that as a bit of a recap next class. So yes, now let's move on to division. So everyone assumes that dividing fractions really sucks, but it's actually very easy. It's almost the same thing as multiplying fractions. There's just a little trick that you use to basically take a division question and convert it into a multiplication question. You don't have to do any long division or any stuff like that. I'll be honest, I have a master's in math and I still don't know how to do long division. I teach it in one of my courses. So usually 5 minutes before the course, I'll learn it, and then it leaves my brain so quickly. Yeah, so let's learn how to divide fractions. So first we have to do a definition. The definition of an inverse or a reciprocal, or you could use whatever fancy term you want. So let's say you have 2/7. So the reciprocal of that, or the invert of that, would just be the fraction flipped upside down. It would just be 7/2. So that's what an inverse is. Another example is like if you have 1/3 and you inverted that, let's make up an invert symbol. Let's do like a arrow and an arrow there. That seems like a logical invert symbol. In that case, you would just get 3/1. Or of course, 3/1 is just 3, so you could just write 3 if you want. So those are reciprocals. So that's going to help us when we divide fractions. So I think I'll just jump into an example and we'll see how dividing fractions works. Okay, so let's do 1/2 divided by 4/3. So this is what you do. For the first fraction, you keep it the same. So that part's pretty easy. And then what you do is you change the sign from division to multiplication. Let's do that. And then the last thing you do is you take the second fraction and you flip it upside down. And then it's equivalent to what it was because changing the sign and flipping the fraction are opposing concepts. They kind of balance each other out. And now you just have a standard multiplication question, and then you just pretend it's a multiplication question. So you just do, so 1 times 3 is 3, 2 times 4 is 8, and that does not reduce. So it's always the same thing. First fraction stays the same, and then this changes to multiplication, and then this does a flipperoo. There's our flipping symbol. And yeah, so it's not too bad. There is an issue with this though. It's that when people see this, they're relieved. They're like, ah, thank God I don't have to do long division or anything like that. you know, I get this, it's fine. And then when the test rolls around, they literally just forget how to do it. Like there have been times where I have like entire classrooms of people that just can't remember how to divide fractions because they just never practiced because they thought it was easy. And it's the type of thing where all you have to say is, it's that question where you flip the fraction and then everyone's like, oh, how did I not remember that? So please practice it and remember it because it's not too bad. Let's do another one. And the logic behind this is that dividing by something is the same thing as multiplying by its reciprocal. That's true in any circumstance. So that's why you're allowed to do that. That's kind of just the definition of division, I guess. Okay, a few more. I have to keep remembering that, okay, so it's 1 to 150. Okay, it's messing me up this weird time. Let's do another one. And then I'll outline some common mistakes that everyone makes. 2 over 3 divided by 4 over 5. So first fraction stays the same, good. Multiplication turns to division. 4 over 5 changes to 5 over 4. So, and then at this point, just pretend that you're given a multiplication question. So 2 times 5 is 10. And 3 times 4 is 12. So this does reduce. And you could actually see that at this point right here, because there's a factor of 2 right here and a factor of 2 right there. So even before you get the answer, if you kind of understand factors, you can see that the answer won't be in lowest terms and you'll have to reduce it. And you just take a 2 out of the final answer. Divide by 2, divide by 2. So you get 5 over 6. You could use cancellation, but if you're going to use cancellation, make sure you only use it during the multiplication part and not during the division part. Otherwise, you're going to be doing like a weird reverse cancellation and you'll get the wrong answer. Okay, so common mistakes. One common mistake is that people will flip the first fraction instead of flipping the second fraction. So don't do that. Just keep the first fraction the same and you flip the second one. Sometimes people will forget to change the sign to multiplication. And then at that point, they get totally confused because it's like, I'm flipping stuff, but there's still a division sign. I don't know what's going on. So you just got to remember, flip it and change the sign. And then there's a super egregious mistake that that drives me crazy. So I will show you that mistake. And it's like, it's such a bad mistake. It's almost like a work of art. It's just that bad. Yeah, so here, I'll show you an example. Let's see, 7 over 11 divided by 3 over 5. So sometimes people who have definitely forgotten how to do the question, sometimes they'll literally just do 7 divided by 3, and they'll put that in. Damn it, my calculator, it keeps giving me mixed numbers for answers, and I don't know why. Anyways, so for that, you would get 2.333, and that would go on forever. And just to clarify, this is the wrong way of doing it. And then they do 11 divided by 5, and you get 2.2, and that's their answer. And it's like, how could you think that's a good answer? It's not a good answer. First of all, it's wrong in every way. It looks horrible. You got a decimal on a fraction. You're totally overcomplicating everything. Don't do that. Yeah, just do the method as presented. Oh, and in this case, let's do the actual question. So 7 over 11 times 5 over 3. 7 times 5 is 35, and 11 times 3 is 33. Does that reduce? No. Actually, you can see that, again, if you look at the original question. 7 is prime, 5 is prime, 11 is prime, and 3 is prime. So it doesn't look like the answer would reduce regardless. Because yeah, you could take a 3 or an 11 out of the top. The bottom, of course, just a 7 or a 5. Obviously, no common factors. So there's a bunch of examples. So use those for practice. Again, practice them because a lot of the times people really just forget these. And then there's a couple of, here, we'll go back to the lesson for a minute. Okay, so examples. So here's just a summary of everything. For multiplication, multiply the numerators together, multiply the denominators, and simplify your answer if possible. And then to divide fractions, change the sign, flip your second fraction. First fraction just chills and stays the same. And here's a link to Math is Fun. Again, check it out because a lot of the times they have like hundreds of worksheets and they have automatically generated answers. It's a really good website. And you could also check out additional material on iLearn because I'm sure there's probably some PDFs that have answers there or have more questions there as well. Okay, let me, if anyone has any questions, let me know and I'll just do the attendance. Stop sharing. And maybe I'll put the webcam on and Buddy can show off as I do the attendance. You okay, buddy? You okay in your shoebox? You're good. There you are. There you are, my buddy. Hello, buddy. Oh, it's okay. You wanna go in the shirt? There he goes. Hey, buddy. And then a lot of the times he'll like crawl onto your shoulder because they like to stay elevated and absorb the sun. Okay, attendance, I already did most of it. So I need that person, got them. Nope. And soon I'll print out a class list so that the attendance doesn't take as long. This person. And yeah, just give me a minute. I got them, I got them, I got them. I got all the Hollies or Haleys. Oh, no, I don't have them. Haley times 2. Let's see. I got that person. So many people. Where's the other one? Julia. Did I get them? Let's see. I got that person. I need that person. Peyton F. Okay. Almost done. I got Steph. I need Steve and Zoe. Okay, so it's 1:42, so I guess that's a good place to end. Buddy can say hi or say bye to everyone. Oh, it's okay, buddy. Oh.
Sorry, did you say on the Math is Fun website you can play games, or was that just a lesson?
On the Math is Fun website, they have like worksheets for various types of problems, and then they'll have like the answers generated for you.
Okay.
So it's really good like that.
Thanks.
Okay, say goodbye to everyone, buddy. Bye, everyone. Man, he looks like his eyes look like dinosaur eyes, and it's always like, it always entertains me. Bye. Give everyone a wave. Oh, okay. So everyone have a great day. Thanks for, when is the deadline for the homework? So for the first assignment, there's no due date yet. We'll just decide on the due date once we finish the chapter. So for now, you're free to work on it, but you don't have to worry about handing it in yet. So I'll stick around in case anyone has any more questions. Otherwise, have an awesome day, and I'll see you tomorrow, right? Yeah, tomorrow. Bye-bye. Bye.
Thank you.
Have a good day.
You too.